Ohm's law. Okay. Right, what is Ohm's law? Essentially, it's a way of predicting how any electrical component or device will behave when you change the voltage across it. So here we have a component. The little square it could be any component. It could be a TV, a hairdryer, I don't know, PS4 or whatever, and it's you're measuring the voltage there, and the ammeter is measuring the current through it. And on the right hand side, you can see a table of results showing you what happened to the current each time that you increase the voltage. So there was 1 volt gave 0.5 amps, 2 volts gave 1 amp, and so forth. And what you will probably know is that if you get the voltage and you divide it by the current, you always get the same value. Roughly, in this case, 2 ohms. Different components will have different values of resistance. The symbol there is the ohm. That sort of, I don't know, a weird bridge thing is known as the ohm. And if you then plot that in a graph, you get this lovely straight line. And V divided by I for any value gives the same value, in this case 2. And that there's Ohm's law. He was the first person to discover it. And he called this value the resistance. Now, Ohm's law can be summarized in an equation which is resistance equals potential difference divided by current. Sometimes this is expressed as resistance equals voltage divided by current. What you need to know is that resistance is measured in ohms, potential difference is measured in volts, and current is measured in amps. This is sometimes summed up as R equals V over I. R is resistance, V is voltage, I is the international symbol for current. And of course, there you get this lovely graph, I equals V divided by I. Now, to be honest, not many components do that, because another factor enters into it is that whenever you pass electricity through a component, it tends to warm up. And when it warms up, you don't get that lovely straight line. You get a bit of a curve like this, and it's probably best demonstrated in a filament lamp. And you would have probably done this at school, a filament lamp experiment, and it shows you that as you increase the voltage, the current increases, but it increases less and less each time. Now, as V increases, so does I, but it's not linear. I rises fastest with the low values. The current rises fastest with the lowest value of voltage, and as you increase the voltage, resistance increases. Now, that's essentially what's happening there. Now, the reason why this happens is because the lamp is getting hotter, and they better explain it in terms of a diagram. Those little black circles with plus in them, they're metal ions. They're the particles that you find inside a wire. And of course, as you heat them up, they vibrate more and more. And the more you heat them up, the more they vibrate. And the more they vibrate, the more difficult it is for the electrons to go through. In other words, the resistance increases. If the particles are hardly vibrating at all, the electrons can find a way through very, very easily. But if they're vibrating loads, the electrons will have loads of collisions with metal ions, and they'll just be stopped from getting from one place to another. And that explains as to why filament lamps, their resistance doesn't stay constant. That there sums up Ohm's law. Ohm's law is the stuff where you've got a lovely straight line. R equals V over I. That is Ohm's law.